Welcome to another exciting educational video brought to you by Up Vision Concept Academy. So today we're looking at IGCSE Maths. Topic for this video is Algebraic Proofs and Identities. So we are looking at basic proofs and identity recognition. At the end of this class or the video, we're going to be understanding what an identity is and how it differs from an equation. Recognize common algebraic identities, prove algebraic statements using correct step-by-step working, explain and simplify expressions to verify identities, construct short algebraic proofs using logic reasoning, and answer IGCSE-style identity recognition and prove questions confidently. So sit tight. If you're here to subscribe to our channel, kindly subscribe to Up Vision Concept Academy. For more exciting videos, share with your friends and engage us in the comment section by commenting and liking our videos. So we dive in. So what is the conceptual explanation for identity and equation? Okay, so conceptual explanation, first of all. So for an equation, example, 2x is equals to 10 is true for some values of the variable. So for this kind of equation, if x is equals to 5, this equation is true. It's true only when x is equals to 5, right? But an identity is true for all values of the variable. Example of identity. Example of identity. Example of identity. So if I have this expression, x plus 2 into x plus 3, the identity is x squared plus 5x plus 6. So this is true. This is true for all values of the variable. Anytime I have this, it's true. Anytime I have anything in this variable and the same thing put here, the both of them are true. So for identity, all the values of the variable are true. But for equation, only one or some is true. Okay, so that's the difference. So we show this by expanding one side and simplifying the other, that's into the other. So this is called algebraic proof. How did I get this? This is an identity, for instance. When you see this, you put this. But how did it come up? I just multiplied this by this to get x squared, this by this to get plus 3x, this by this to get plus 2x, and this by this to get plus 6. So this now becomes x squared plus 3 plus 2 is 5x plus 6. So this is an identity for this particular case. So we're going to be looking at key algebraic identities you need to know for IGCSE. So we're going to the key algebraic identities you need for IGCSE. So the first one is if I have a plus b all squared, the identity is a squared plus 2ab plus b squared, right? So expanding this, you get this. Okay. Second one is if I have a minus b all squared, the same thing as saying a squared minus 2ab plus b squared. So this is the identity for that. I have number 3. If I have a plus b, open bracket, close bracket, into a minus b, this is what we call the difference of 2 squared, just to say a squared minus b squared. Okay. And number 4 is x plus h all squared. Okay, it's similar to the first one. Just say x squared plus 2xh plus h squared. And you have this, number 5, a plus b plus c all squared. Very interesting. So this is, you use like a binomial expansion. You get a squared plus b squared plus c squared, then plus 2ab plus 2bc, then plus 2ca. Okay, let me put it here. Plus 2CA. You see? AB, BC, CA. All right. So visual idea, you can think of expanding like opening a folder or a folded box. Each term multiplies every other term. So you take it step by step. Like this one now. This is a square. This is A minus B square. Sorry, A minus B, right? Then again, A minus B. So this one, just like I said the first time, multiply this by this, multiply this by this, multiply this by this, multiply this by this. All the answers, simplify together to get what you have. Okay, so I have this on the board. It said we should prove that x plus 4 all squared is equals to x squared plus 8x plus 16. Now, what we are asked to do here is to expand this, showing how your workings, whatever you arrived at must be equal to this. Must be equal to this. So I'm going to expand this on this side. And at the end of the day, what I arrive at must be equal to this. That's what I'm asked to do here to prove. Okay, so the first thing to do now is to just do open bracket on the left-hand side. Work on the left-hand side. All right, so I say x plus 4 and x plus 4. So this is what I'm asked to expand. So like I said, x times x is x squared. X times 4 is plus 4x. Then I'm done with this one, multiplying each of the two. Then go to this, plus 4 times x is plus 4x, and plus 4 times 4 is 16. Okay, so I work on this further. So these are like terms, so I'll add them. So I have x squared plus 4 plus 4 is 8x, then plus 16. So this is equal to this, meaning that I have proven that this identity is correct, right? Okay. Okay, so this example says we should show that 2x minus 3, open bracket, close bracket, into x plus 5 is equals to this. So again, I'm going to expand the left-hand side of this equation, expand this, and whatever I get as my answer should match this, showing that this is an identity. Okay, so the first thing I do is to work on the left-hand side, and I have 2x minus 3, close bracket, open bracket, x plus 5. So I now say 2x times x is 2x squared. 2x again times 5 is plus 10x. Because 2 times 5 is 10 and x is x. All right, so minus 3 times x is minus 3x, and minus 3 times 5 is minus 15. So I work, just these center terms are like terms, so I will just work on it. So I have this first term is 2x squared, then plus 10x minus 3x is 7x, plus 7x, then minus 15. This and this are equal, showing that this identity is true. Okay. Okay, so if I this question on the board, it says prove the difference of two square identity. That is, show that a plus b, a minus b is equals to a squared minus b squared. A time will come when this thing should just be on your head. When you see this, or when you see this, they are identities. This can replace this, and this can replace this. But how can we prove this? If I expand this, and what I get at the answer matches this particular one, then identity is verified. So again, a plus b, a minus b, a multiply a gives a squared. Same a multiply minus b give you minus ab. Okay, then plus b multiply a is plus ba, and plus b multiply minus b squared. Now these center terms are the same thing. AB and BA are similar, are the same thing, because A times B, the multiplication there is commutative, meaning that I can switch it. I can switch it. It's like saying 2 times 3 is equals to 6, or 3 times 2 is equals to 6. It's the same thing. So if I have A times B is equals to B times A. So these two are the same thing, right? So I say A squared minus AB plus AB. I've switched it now. So that it can look really alike. They are actually alike, but switching it to give me a visual proof that is the same thing. So minus B squared, right? So minus AB plus AB, these two will cancel out. They will give me 0. So I have A squared minus B squared, which is the same thing as A squared minus B squared as before. Identity is verified. Identity is verified. You can put this in your answer. Okay. Okay, so I have example 4. Say show that x squared minus 9 over x minus 3 is equals to x plus 3 for all x not equals to 3. Now, what happens if x equals to 3? If x equals to 3 here, it means that 3 minus 3 is 0. So denominator is 0. So I have this over denominator is 0, which is giving us not the same thing as this. So the only condition is that x must not be equal to 0. So not equal to 3, so that the denominator not become 0. If x is equals to 3, the denominator will be 0. And if the denominator is 0, it means that the whole of this expression, whatever I have here divided by 0 will give me indeterminate or infinity. And infinity is not equal to this, obviously, no matter what. Okay, so this is the only condition. So the first thing we'll do, now we know that x must not be equal to 3, we can just come here and factorize the numerator. So I will say factorize, work on the left hand side, working on the LHS. You can define it as left hand side. You can itemize what you are doing. In mathematics, you can just write a short note, what you are doing gradually, step by step. So I'm working on the left hand side. Okay, so then I will now factorize the numerator. This is x squared minus 3 squared, because 9 is the same thing as 3 squared, right? All over x minus 3. All right, still on the left hand side, this is actually difference of 2 squared. We have done that before when we say a squared minus b squared is equals to a plus b and a minus b. We have done that. So the same thing, saying x squared minus 3 squared is x minus 3, x plus 3. Okay, so we're going to do that here. So this is x minus 3, x plus 3. Okay, all over x minus 3. Okay, so this can cancel this. So I have x plus 3 on the left hand side, which is still equals to x plus 3 on the right hand side. So since left hand side is equals to right hand side, identity is verified. So, we are to prove this identity, this left hand side equal to this right hand side. What I have here is equal to what I have here. So this is left hand side and right hand side. So I'll say working on the left hand side, working on the left hand side. So I will expand this term, x plus y square, to be, again, this one is, identity of this one is x squared plus 2xy plus y squared. Expand this one. Identity will be x squared minus 2xy plus y squared. Now, I haven't gotten this and this. I'll just put them here. For this one, I'll write this. So I'll say x squared plus 2xy plus y squared, then minus, then this one, x squared. Now this is minus, so I'll put my minus, my bracket first. See, this minus here, you put it here, then put brackets. Don't just start writing this one down, because this minus outside will affect every operation inside, right? So make sure your bracket is there so that you can have a visual boundary. Okay, so I have minus again, 2xy plus y squared. So I'm going to expand, remove these brackets, let this minus operation work on every other operation inside here. So I will say x squared plus 2xy plus y squared minus, so minus times plus x squared is x squared, minus times minus is plus 2xy, minus times plus is plus, no, not plus, minus y squared. Okay, so at this point, I'm now going to collect my like terms carefully. So this and this are like, so I will say x squared minus x squared. Then this one and this one are like, I will say plus 2xy plus 2xy. Then this one and this one are like, I will say plus y squared minus y squared. So this one, x squared minus x squared is 0, plus 2xy plus 2xy is 4xy, plus y squared minus y squared is 0. So I'm left with this. And this is also equal. This is left hand side. It's also equal to the right hand side. This is the right hand side. So therefore, LHS is equals to RHS. Identity is verified. Okay. Past IGCSE maths questions. Number 1, prove that y minus 4 all square minus y plus 4 all square is equal to minus 16y. So solution is to expand the left hand side. So I'll say working on the left hand side, working to expand the left hand side. Always define it. LHS, what it is? In bracket, left hand side, right? So I'm going to expand this first term here. This is a term. So y minus 4 all square. So this one is the same thing as saying y square minus 8y then plus 16. All right. This one, y plus 4 all square is equals to y square plus 8y plus 16. Okay. At this point, if you don't want to expand, use that what I gave you. Okay, let me come here and explain it again. I don't want to be explaining this all the time. This is y, right? Y minus 4, open bracket, y plus 4. This is, expand this, multiply this by this first, and this by this first. The first one is y squared, that's this by this. Second one is plus 4y. Then multiply minus 4 by y, minus 4y. Then this one now, minus 16. So when you do this, you get y squared minus 8y minus plus 16. Yeah? Okay, what I'm even doing here is wrong. This is y, this is plus, so this is plus here. Okay. For the second one, right? Okay. So let's continue. What I did there is correct. Just do the expansion. So when you have done the expansion, the next thing to do is to take this, for this and put here, this and put here. So for the first one, I have y squared minus 8y plus 16. Then minus again, this is the minus, then do a big bracket to accommodate what I have here, that's this one, y squared plus 8y plus 16. Okay, so I'll work on the brackets later, but let me just write this out first. Y squared minus 8y plus 16. Then this minus y squared, then minus times plus is minus 8y. Then this times plus again, minus 16. Okay, so at this point I collect like terms. This and this will cancel out. This and this will cancel because it's plus and minus. This and this will also cancel out because it's plus and minus. So I have this and this. I have minus 8y and minus 8y. It will give me minus 16. Minus 16y on the left hand side is the same thing as minus 16y on the right hand side. That means I've verified this. This one is true. Okay, still on IGCSE past questions, so I have this on the board. Now I should show that this expression here is equals to this. Okay, so working on the left hand side, I'm going to expand the numerator. Expansion of numerator gives me x squared minus 16 is actually 4 squared all over x minus 4. Look at this numerator very well. See that it is having the identity of difference of 2 squared. So I'm going to write this as x minus 4 and x plus 4, all right? All over x minus 4. So here, I cancel this. What I have left is x plus 4, which is equals to x plus 4 on the right-hand side. This is the left-hand side. What I've done here, left-hand side, right-hand side. So this identity is proven to be true. So in your IGCSE questions, ensure that you have consistent methodology. You fully expand and simplify. You don't miss the signs. Especially for the one that I did the previous example, you don't miss the signs. Make sure that your signs are correct. When you are opening a bracket, let the sign outside work on the operations inside to change them as the case may be. Okay, so also ensure that you get your factorization correctly, you get your cancellation correctly, and the final answer, you get it correctly. So I hope this video has been informative for you. I'd like to thank you for viewing.